Okay, class, welcome to laboratory number 2, projectile motion. Okay, so now we're going to study a person on a bicycle. They're going off a ramp, right? So they have a velocity going in one direction. Of course, as soon as they're off the ramp, then gravity, force of gravity starts acting upon them. Okay, and we're going to examine it, study it, and figure things out using math, because that's what we do. Let me get my camera set up. Okay, it looks pretty good. Looks pretty good. All right, should be good enough. So this is the Canvas page for the lab, and you're going to read the instructions carefully, follow all the instructions. You're going to come to this link here, you're going to click on a link, right? We've done this before with the previous lab. Okay, there's a little warning, don't try this at home, this was done by professionals in a computer lab, right? Don't hurt yourself, hit begin. Okay. Now you have some arrows here. Here's a person on a bicycle, right? They're on a ramp, and they're going to be going some distance. You can adjust the height of the ramp with these arrows, right? You're going to write that down in your table that you're going to make, right? So here you got height of the cliff, meters. So this looks like 2.12. This looks like I have it set at 2.2 meters, right? Then to launch the person, you give them a little signal, click on them, and they launch, right? So now, it's the distance. You're going to measure the distance from here to where the back tire hits. That's also in meters. So it looks like this person went just a little bit more than 5 meters, right? You can get it as close as you can, estimate in between. You write down that value. Okay, and then, for additional runs, or if you didn't like a run, you hit reset and you start the whole thing over. Then you're going to calculate the time, right? Read the lab, and then you're going to calculate the horizontal velocity that this person launched off with. What's interesting about gravity, of course, is velocity in this direction stays constant. Because all it is just the velocity that this person, they accelerated up, they have to accelerate the bike from a stop up to the end of the ramp. But once the ramp, then that's it. Whatever velocity they're at the end, and that velocity just stays the same. We're ignoring air resistance, right? That velocity stays the same. But the downward, that's an acceleration. That's a force, so that's an acceleration. So for given chunks, the velocity is always the same, but for the downward direction, for given distances, it keeps getting bigger and bigger because it's accelerating downwards. Okay, folks, and then